Hi, Assalamualaikum warahmatullahi wabarakatuh. This is second part of our revision lecture for chapter 3 now. And I hope we will be able to discuss a lot of things today. And firstly, I want to talk about a reaction rate. What is reaction rate? Reaction rate, if we have rate, we would have over time. So we would measure the concentration of the reactant and product. If the question asks you to write the differential rate equation, then according to the general equation, AA plus BB becoming CC plus DD, and you would have this negative 1 over A, the stoichiometric coefficient there. The negative signs is because we are reducing the concentration of reactant, whereas the positive sign for C and D here is because the concentration of product is accumulated. So this is the whole differential rate equation. Let's do a question from the back of your chapter in the book. Nitrogen monoxide NO is an atmospheric pollutant formed from the reaction of nitrogen and oxygen gases in the internal combustion engine. Sometimes questions are given for us to give you information, more knowledge. Nitrogen monoxide is reduced by hydrogen gas to nitrogen gas and steam. So what the second sentence is trying to say is that nitrogen monoxide here is reduced by hydrogen gas, and then it will form nitrogen gas and steam, H2O. Okay, steam in gas, nitrogen in gas, hydrogen in gas, and also nitrogen oxide also is gas, nitrogen monoxide. Now, the second thing is we need to balance the equation. We need to write the chemical equation. So if we have 2 nitrogen, we put 2 over here, and we have 2 oxygen, we put 2 over here, and then we have 4 hydrogen, we put 2 over here. So this is the balance equation for the reaction. In an experiment, the rate of formation for nitrogen gas, in the question, the rate of formation for nitrogen gas is given 3.4 times 10 to the power of negative 2 molar per second. Write the differential rate equation. So as we follow the previous slide, we put negative 1 over 2 dNO over dt. Ini persamaan perbezaan kan? Negative 1 over 2 dH2 over dt. And this is equals to the formation of, here there is 1 mole, so dN2 terus over dt equals to plus, because this is accumulation of product, 1 over 2 the concentration of steam over dt. Now, the question gives us the formation of nitrogen gas is 3.4 times 10 to the power of negative 2 mole per second, meaning that we want to find the rate of disappearance of NO, which is this one. So we put negative. Negative represents disappearance. dNO over dt is equals to 3.4 times 10 to the power of negative 2 multiplied by 2, because the stoichiometric coefficient for the disappearance of nitrogen monoxide is 2. So 3.4 exponential negative 2 multiplied by 2 is 0.068 molar per second. So this is the answer for question number 2. Predict the disappearance of H2 gas. Now, the disappearance of H2 gas is here. Okay, so the disappearance of H2 gas would have the same magnitude, the same value with the disappearance of nitrogen monoxide because it has the same stoichiometric coefficient. So you can say this is also the disappearance of H2 over dt. So make a bit of a statement. The rate of disappearance of hydrogen gas is the same as the rate of disappearance of nitrogen monoxide gas because it has the same stoichiometric coefficient, which is 2. And that would be your answer for this question. Apart from the differential rate equation, we are going to learn about rate law. Rate equals to K a to the power of 0 if it is a zero order reaction. So if we integrate this formula, we would get A equals to negative KT plus A naught. And if we plot A, concentration of A against time, we are going to get a curve. Okay, but certain books, they just do it straight line like this, whereby the gradient would be the negative k. And if we want to find the half-life, okay, the first half-life would be here. Okay, it would be 2 times longer than the second half-life. Then we would determine that this reaction is zero order reaction. Zero order. And there is another equation, integrated equation, where you are going to develop a straight line graph originating from 0. Okay, and then another thing that you need to remember is the formula for half-life. For first order reaction, we have rate equals to Ka to the power of 1. The integrated law equation would be ln A. So we remember that the first order, it will involve ln negative Kt plus ln A naught. Okay, and we notice that if we plot ln A against time, the gradient would give a negative K, and if we plot concentration of A against time, the half-life would be the same. This shows that the half-life of first order reaction does not depend on the concentration of initial reactant. And we also have to remember the ln 2 over K is not that difficult too. So next, second order reaction is when we have rate equals to K a to the power of 2, and when we integrate it, we are going to get ln A equals to Kt. Now it is a positive gradient plus 1 over A naught. So we're going to plot 1 over A against time, and we're going to have a positive gradient with the y-intercept there. If we plot concentration of A against time, okay, we are going to have the first half-life is half. The first half-life is half, and the second half-life is 2 times more than the first half-life. If we got this trend, it would be second order reaction. And the formula to calculate half-life is 1 over K multiplied by the initial concentration of the reactant. Let's try do one question from the back. Dissociation of dinitrogen pentoxide, blah, 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 has a rate constant of blah, 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 blah. So we can see here that in the question, what is given to you is the unit of rate constant, because we are not given which order it is. We need to figure it out. This is using unit of rate, the second method in your third lesson. So if we have molar -1, second -1, this means that the order of reaction is second order. Okay, and we need to solve A, where we are going to use the integrated rate equation, which is 1 over A. This formula, I'm sorry, but you have to memorize 1 over A. It's not that difficult. Okay, and then we want to find the A naught. No, we want to find the A. We are given A naught, which is 0.35, and then the minute is 4.5 times 10 to the power times 60, sorry, and then K would be 6.13 times 10 to the power of -5. So let's press the calculator. 6.13 exponent -5 multiplied by 4.5 multiplied by 60 equals to 0.016551 plus 1 over 0.35. We got 2.87369. Okay, 1 over it, and we get 0. A naught is 0.348 molar. So we get the answer for A. Now for B, find the time required for 27%. So 27% from the initial concentration to decompose means 27% decompose means this is the amount of product. We want the amount of reactant because in the integrated law equation we are dealing with reactant initial and reactant at the T time. So if the A naught is 0.35, okay, what is the A? The A would be, because 27% is the product, then 100 minus 27 is 73%. 73% of 0.35 would be the A. Yes, it would be the A. So the answer is 0.2555 molar. Okay, what is that? 2555. 3 fives. Okay, this is the A. So we insert into the formula. Okay, this time I want to use A minus A naught because it's easier, because I want to find T. Kan? So this part you just go over here. So choose below. 1 over A would be 0.2555 minus 1 over 0.35. So K is 6.13 times 10 to the power of negative 5. And you want to find T. Now, T would be, let's press the calculator together. 1 over 0.2555 minus 1 over 0.25. Okay, and then divide by 6.13 exponent negative 5. You got 17239.01. This one we have to divide by 60 lah, because it's a very big number. We get 287.3 minutes. Ini seconds. Okay, this is the answer for question D. Now for question D, determine the half-life when the initial concentration is the same. So what is the formula for half-life? The formula for half-life is half-life equals to this is second order, right? Ka naught. Yeah, I remember that. T half-life equals to 1 over Ka naught. So 1 over 6 times 0.13 times 10 to the negative 5 multiply by A naught is 0.35, and the answer would be 1 over 6.1, sorry, 13 exponent negative 5 untuk kurungan 1 over 6.13 5 untuk kurungan sama dengan, dan over lagi 0.35 sama dengan 466.09. Yeah, the answer is 466. Oh wow, what's that? 46609 seconds. Okay, you can convert it into minutes. Just to get a beautiful number, 0.8. Ni bawah sikit kan? Right, we got number C. Now sketch a graph of concentration of N2O5 versus time. So if you sketch a graph, the graph would be like this. Okay, concentration of sorry, this is not A, this is N2 over N2O5 against time. It would give you a graph like this. Okay, where you can say that the X, the first half-life is X and the second half-life is 2X. Okay, and then here is the concentration of initial. So this is the sketch of the first graph. The second graph is you want to plot the rate against concentration. So it would become like this because we are dealing with only one type of reactant. Okay, and finally, when we are plotting 1 over reactant against time, we will get that graph, 1 over N2O5, because this is the graph for this equation. So basically, we've done this question A, B, C, D, 1, 2, 3. If we are given a balance equation where we have reactant, we will have to write rate law equals to K equals to something to the power of X, something to the power of B, if it has two reactants. So we need to find out X and Y using initial rate method, because the order of reaction can be determined only experimentally. Okay, and then we can also determine the order of reaction by using the unit of rate constant, like the one that we did just now. M-1, S-1 is for second order. Ini contoh. And then we are going to draw half-life graph and then look at the trend for first and second half-life. It is the same, then it would become first order. This is how we determine the order of reaction. And then linear graph method is also can be used to determine the order of reaction and to establish and verify the order of reaction that is given in the question. Right, let's do a question on initial rate method. The reactant here is 2-chloropropene. If you remember how to name the organic compound here, this is carbon number 1, this is carbon number 2, has Cl, kan? This is carbon number 3. So that is why it is substituent, we give the name 2-chloropropane. So we assume this is A and this is B. We give the name A and B because we want to put into our rate law prediction, rate equals to A to the power of X and B to the power of Y. Where we got B and Y, then we can replace back A and B because it's quite a long thing to write. Now, we are comparing experiment 1 and 2 because the element of this one is the same. So what is the rate? 3.0 times 10 to the power of negative 3 equals to K, and then we have 0.15 to the power of X and 0.25 to the power of Y. Okay, compare it with experiment 2. The rate is 6.0 times 10 to the power of negative 3 equals to K, 0.15 to the power of X, 0.5 to the power of Y. So here we can cross out all the same things. Okay. And then what is left is 3 over 6 is 1 over 2 equals to 0.25 over 0.5 is 1 over 2. So we know that y is equals to 1. So y is which part? This part. So the order of reaction with respect to NaOH is first order. Okay. And then the second step is we want to compare between the first experiment and the third experiment. So 3.0 times 10 to the power of negative 3 equals to K, 0.15 to the power of X times 0.5 to the power of Y. And divide this with experiment 3. 9.0 times 10 to the power of negative 3 equals to K, 0.45 to the power of X and 0.25. Oh, this one is 0.25. Okay, sorry. And then we can cross out this one, cross out this one, cross out this one. We are left with 1 over 3. 1 over 3 equals to, this is also 1 over 3. Okay, and this is to the power of X, therefore this is to the power of 1. Here we know that X is also equals to 1. So the order of reaction with respect to 2-chloropropane is also first order. And then it asks us to write the rate law. So now we want to write a proper one. Rate equals to K, okay, CH3, CH, Cl, CH3, aqueous, okay, alright, this is to the power of 1 and NaOH is to the power of 1, okay. Based on the following concentration data as a function of time, determine the behavior of the half-life as the reaction progresses. Use this information to determine if the following reaction is 0, first, second order in A. So let's plot a graph, okay, of the concentration of A in molarity, okay, 2 against T, time in seconds. So at 0 time, the concentration is, let's do a proper scale, 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be 1.2. So this is at 0 time. At 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 10, okay, it would be 1.1, 1.0, 0.9, 0.8. Okay, this is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so at 0.8 it is 10. This is 10 seconds, so it is here. At 0.6, 0.6 is here. It is 20. This is 20. Okay, so basically it is going very steep there. It's going very steep. Tak boleh lagi plot. 0.48 is over here. It will be 6, 0.5, 0.4. It would be here. Okay, it would be very steep. And then 0.4 is 40, 30, 40 is here. And then 0.343 is 50, 343 is here. And then 0.3 is there. And then 0.26, okay, 0.21, and finally 100. So it's going to be a very steep, long one. Okay, the first half-life 1.2 is 0.6 here. Okay, so this is the first half-life. Okay, the first half-life is actually 20. Okay, first half-life is 20 seconds. But the second half-life is 0.6 divided by 2 is 0.3 is here. So what is the time? The time is 4, 5, 6, 7. 6. 0.3 is 60. So 60 minus 20. 60 minus 20 is 40. 40 seconds. So the second half-life is 40 seconds because 60 minus 20. This is the first half-life, and then this is the second half-life. Second, first. So we found that the second half-life is 2 times than the first half-life. Therefore, this is the second order reaction. So if the question specify for you to draw a half-life graph or use the half-life to determine the order of reaction, this is what you have to do. Alright? Use the data to estimate the rate constant. How to use the rate constant? So half-life equals to 1 over k A naught. Okay? The half-life we already know, which is 20. This is 20. And then A naught is 1.2 molar. So we can get K equals to 1 over 20 times 1.2. So K would be, where's my calculator? 1.2 times 20. K would be 24, 24 per molar per second. So here is how you answer this kind of question. Now, for this question, few students have been asking, how do we know which graph to plot? If the question asks you, verify, then you have to plot ln A versus time. But if the question asks you determine the order reaction, then you have to plot A versus time. But for this question, what does it say? The data listed in table below were obtained from the following decomposition reaction. Establish the order of reaction. Establish means determine. Determine the order of reaction. So it is easier for you to draw a graph, plot a graph of concentration of A versus time, and then when you get the curve, you would find the first and the second half-life, and then you would find out that X is equals to X, therefore it is first order reaction. But if the question say the reaction below is first order. So the question has stated that it is a first order. And then verify. The word verify states that you have to double confirm that the reaction is first order. Therefore, you have to plot ln A versus time, and then you will get the negative gradient, and then you will count or calculate the negative k so that you can find the half-life later. For this graph, you would find the half-life and use the formula to get k. But for this graph, you find the k and then you find the half-life using the formula. So basically, I'm just giving you a brief talk or discussion on how to tackle this kind of question. So good luck on plotting the graph. In order for reaction to occur, molecule must collide. Number one. And then the molecule also has to have sufficient energy in the form of EA. The collision must be in a correct orientation. That is the three things that we have to have in order to get an effective collision. So I'm showing to you here is the reaction profile or energy level diagram on exothermic reaction, whereby the reactant here, carbon monoxide and nitrogen dioxide, will have EA, forward reaction, as much as that high, and then on top of here is the transition state, whereby activated complex will be formed temporarily, and then when it is turning into product, it is going to use up its delta H, the enthalpy, and then delta H together with EA forward reaction will give us the EA reverse reaction. So basically, if you remember exothermic reaction, you can derive the endothermic reaction, inshallah. There are 5 factors that will affect the rate of reaction. The higher the concentration, the faster the reaction will be. And then if the pressure is increased, the volume of the container will decrease, making the molecules are closer to each other, making the number of collision increases, and this will increase the rate of reaction. Temperature generally will increase the rate of reaction, catalyst will speed up the reaction, and particle size will increase the rate of reaction for a smaller size of particle. So basically these 5 factors will affect the rate of reaction. Let's look at this Maxwell-Boltzmann distribution curve. Okay, there are 2 questions that's going to come out in a minute regarding this. You need to decide which curve has the higher temperature. Is it T1 or T2? Yes, the higher temperature is T2 because the area under the graph is higher or larger. So you need to know that Maxwell-Boltzmann distribution curve is plotting the number of molecules against energy. And then the EA is the energy that is needed in order for the reaction to occur. So if we use catalyst, the EA would be in front of here. So more molecules would have enough energy to react. Therefore, the reaction will speed up. This is the Arrhenius equation. Arrhenius equation. Okay. If we ask you what is Arrhenius equation, this is the one that you have to state. The general ones where it has rate constant, gas constant, absolute temperature, base of natural logarithm scale, and frequency factor. We are not familiar with frequency factor as it's not going to be given in the question. Therefore, we are going to use a lot of this formula. Given K1 and K2, T1 and T2, what is EA? Because R is 8.314. Another question that is going to come out is for us to plot graph. Because when we plot the graph of ln K against 1 over T, we are going to get a negative slope where the gradient would be negative EA over R, and therefore we can find the EA. EA must be in kilojoule per mole. Let's do one question. Write a rate law for the dimerization of 1,3-butanediene. What is 1,3-butanediene? You have 1, 2, 3, 4. This is 4 carbon. And then between carbon number 1, there is 1 double bond. Between carbon number 3 and 4, there is 1 carbon. And then you fill up all the hydrogen that can occupy the C's. So this is 1,3-butanediene. The rate law, rate equals to K, put butanediene over there, C4H6, okay, to the power of 2. Because it says here is second order, right? What is the unit for the rate constant? I think all of us remember it's M -1 S -1. But if you don't remember, you can find it from here. How? Put K in front, put rate on top, and then put C4H6 at the bottom to the power of 2. So find the unit M -1, M kuasa 2. So this will go off and you would have M -1 as -1. So this is the unit for the rate constant. Okay. Okay, let's do number B. An experiment was carried out at 300 degrees Celsius to determine the rate constant for the reaction. When 0.1 mole kn cube of C4H6. The initial reaction rate is 5.38 times 10 to the power of 95. What is the rate constant? So it wants to find K. So we have the rate. We have the rate. We want to find K. Do we have the concentration? Yes, the concentration. So we're just going to use this formula. Okay, this formula. Right, rate is equals to 5.38 times 10 to the power of negative 5 equals to K is the one that we want to find. The concentration is 0.1 to the power of 2. Is that right? Okay. So therefore, K is 5.38 exponential negative 5 divided by 0.2 divided by 0.1 dua kali. So it's 5.8 5.38 times 10 to the power of negative. Okay. So the unit is -1. Please write the unit carefully. It won't lose the mark. Now C. The rate constant changes when temperature changes according to Arrhenius equation. Ada stamp tu dia nak beritahu yang kita akan guna Arrhenius equation pula lepas ni. The initial reaction rate of experiment at 400 degrees Celsius using 0.1 molar of C4H6 is blah 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 blah. So it is giving you another rate, rate and another K. Calculate the new rate of another experiment at 400. So, okay, let's revise the Arrhenius equation that we're going to use. Ln K1 over K2 equals to EA over R 1 over T2 minus 1 over T1. So we have we need to find the new rate by using this technique. Okay, so putting in the rate, the initial reaction rate is 1.75 times 10 to the power of negative 3 equals to K 0.1 to the power of 2. So the K would be, where's my calculator, 1.75 exponential negative 3 divided by 0.1 divided by 0.1 is 0.175 per molar per second. And then let's put the K, this is K2 for example, and this is K1. So the experiment is at 400. Okay, this is T2 and this one is T1. Okay, so let's put it into Kelvin and use 273.15. Okay, so ln 5.38 times 10 to the power of negative 3 over 0.175 equals to EA over, what is our R, 8.314. Okay, 1 over, that is T2, right? So T2 is 400 plus 273.15 is 673.15 minus 1 over 300 plus 273.15, and that would be 573.15. Okay, solve for EA. Okay. EA is, pause the video and then do the calculating. 111,586.495. It might have a slight change because the answer that I'm using here doesn't use 0.15. So convert it into kilojoule per mole, it would be 111.586 kilojoule per mole. Right? So that is how you answer question number C. Now we have one more question. You need to sketch the diagram for energy profile. Where should I do that? Yellow. This right. Okay, let's do it here. Where we have this is energy and this is progress of fraction. Progress of fraction. And then this is exothermic. Remember, exothermic, the reactant would have a higher energy, and then it will go up to the EA, and then it will go down to the product. So you label the product. The product is C8H12. H12. Okay. The product, the reactant would be C4H6, and then this would be the delta H, and this would be the EA forward, and this would be the EA reverse. So the EA there is already calculated, 111 kilojoule per mole. The delta H also, if you want to put, negative 150 kilojoule per mole. A question might ask you, what is the EA for reverse reaction? Just total up 111 with 1 factor. So that's all. Thank you very much for listening, and I hope you have a good day preparing for. Oh no, I forgot to discuss with you the most important question. What is it? Rate constants K for decomposition of hydrogen iodide at different temperatures are given in the table. So you are given basically 4 points to be plotted. Write the Arrhenius equation. So I've told you what are they, the ones that is general, having all the constants. And then plot a graph ln k against 1 over t. The question specifies you to find ln k. Okay, write another column, and then another column for 1 over t. Here you're going to get 1 mark for 4 points to be plotted. And then as you are plotting the graph of ln k versus 1 over t, you are going to get a straight line graph with a negative gradient, where when you get the gradient from the graph, you are going to find the EA, obtain the value of EA. How is that so? Because we are actually plotting ln k equals to negative EA over R 1 over t plus ln A. So here is the ln A, the y-intercept, and then the y-axis is ln k, the x-axis is 1 over t. We are going to get negative m, where the gradient is actually the same as negative EA over R. The R is 8.314, and then you are going to get EA in kilojoule per mole. Convert it because this is in joule. Okay, so I hope you would take some time, 10 to 12, 15 minutes to plot this kind of graph, as we're going to give 1 mark for axis, as usual, 1 mark for shape, 1 mark for the 4 points, 1 mark for the gradient, and then 3 marks for calculating the EA. Altogether is 1, 2, 3, 4, 5, 6, 7, 8. At least 8 marks for this. It's very critical for you to be able to draw this graph, linear graph. Thank you very much, and I hope everybody can get A in your mid-semester exam of semester 2, 2021-2022, inshallah. So, assalamualaikum warahmatullahi wabarakatuh. Bye.